And yesterday I think we also saw some more methods of the some methods. We started with some methods of the thread class. Quick revision of what were the methods we looked at yesterday related to the thread class. Yeah. So in any thread of we understood that thread of execution is a separate runtime stack basically. Okay. So in order to have a separate runtime stack which is executing my parallel job, right? I must be having a runnable, and then the steps were there. Okay, let's just go through what was done yesterday. Okay, here it is. Okay. Thread of execution. How do we create a new thread of execution? This was only to, okay, this was just to recollect the garbage collector thing. Okay. Steps, here are the steps, right? 4 steps. The third step is an optional step. Okay, only when you feel like, okay, I want to change certain properties, you may do that. Okay, relation between thread object and thread of execution. Okay. Okay. Static method of the thread. Now here is where we started with the methods. So in any class, right, in any of the methods, if you call the static method called current thread, it will give you the thread object. Right? We understand thread object is separate where all the properties are available. Okay. Right? Plus there are various methods when you call on the thread object. Right? The behavior of this thread of execution is going to be affected. Okay, so we have this method called current thread to give us a thread object, right? For example, the first thread which is started is the main thread. We never created the thread object, but we are interested in getting that thread object. We can get it in the main method. Just call this method thread.current thread, right? So it's a static method, call it like this. So you get the thread object even for the main thread. Okay, fine. Then every thread object has a name. So we have got the get and set method. You can change the name anytime. Every thread has a priority, right? It's an integer value. Okay, so you have the get set methods, and the priority values are like this. The range for the priorities, okay, it's between min priority and max priority. The values are 1 to 10. Okay, we have something called a norm priority. Fine. Norm priority is the initial priority for the main thread. Fine. Okay. Now, what is the priority of a new thread? And the priority of a new thread is the priority of the creator. Fine. So, creator means the creating thread of execution. Okay. Fine. See, someone says new thread, right? The execution happens from a thread of execution, from a runtime stack. Okay. But corresponding to that, there is always a thread object. Okay, there's always a unique thread object. Fine. Okay. I think I'll add one more statement at this place. Right? Where we have written those 4 steps, I need to mention one more thing on a thread object. Start. Okay. Start method can be called only once. Okay. If you try calling another time, it will throw a illegal state exception. So this ensures that for a thread object, fine, or for a thread of execution, there is a unique thread object. Okay, and there will be one thread object. If you have a thread of, if you have a runtime stack, then there is always a thread object for it. Okay, but other way around is not necessary. You may have a thread object, but there is no thread of execution. Okay. See, I'll try to follow a slightly different convention when I now create a figures. Okay, it's something like this. Okay, we have a uh, thread object, okay, where priority and other things are maintained, okay, and there is a execution sequence. So on a timeline, yes, it is executing, okay. And so this is the way we see the relationship between them, okay. So for this is your execution happening on a runtime stack, that's represented by this line, and this is the corresponding thread object, okay. So always there are two of them, fine. So it's like this, we saw the states of thread yesterday also, right? So it was like, okay, so first thing what happens is, oh, you create a thread object, there's no thread of execution, fine. Calling start on a thread object. So first thing would be, okay, create a thread object. Thread has a runnable object, fine. So the run method of the thread knows what it should be doing, okay. It has to just simply call the run method on the runnable object, okay. But when will it call that? Okay, so for that, yes, first thing, uh, so what we do is, yes, one of the steps was set up the properties. So you set up the initial properties on the thread object, okay, and calling start on this object. So when you call the start method on this object, okay, when someone calls start method on this object, then this begins the execution, okay, fine. And then after the execution, yes, it finishes that method. If it finishes the method, which is the target method, fine, then there won't be a execution sequence, but the thread object can still be there, okay. So if there is a thread of execution, fine, if there is that runtime state where something is executing, for any thread of execution there is a thread object. Yeah, fine, the two are related. The execution which happens is a separate thing, and there is a thread object maintaining information. Plus it has methods which you can invoke certain methods on this object, fine, and that would affect the, fine, which can either give information related to what's happening on that runtime stack, okay. For example, we have this method here. On this you can call a method and it would return a, so get stack trace, right? Fine, we saw this method yesterday also. We have this method called the get stack trace, okay. So that would tell us about the runtime stack, picture of the runtime stack, okay? Okay, fine. So clear, object and a execution sequence, object of thread, yeah. Yeah, then this comes the runtime stack. Yeah. And it would be loaded with the run method. It's basically, it's loading the run method of the thread class. No, we don't have to call anything. That's it, just calling the start. When we call the start, the new runtime stack is there on which the run method of thread is available. See, the run method of thread is quite simple. I'll write it there. Okay, what's there in the run method of the thread? Okay. Okay, let me put it into this. When start method is invoked on a thread object, okay, which we understand is only once you can do, okay, okay. run method of the, or okay, run method is invoked. It's not the start method who is invoking, understand this, right? It's in the runtime stack, okay, new runtime stack, that the run method is invoked, okay, just like the main method was invoked, right? On the first thread object, main is invoked, okay, fine. And on the other thread objects which you create, it's only the run method on the run method is invoked, fine. Okay, is invoked on the thread object, okay. Run method of the thread, okay, and just showing you the portion of the, okay, so the run method is something like this. In the thread class, public void run, and it would simply do this. It would say, okay, if target is not equal to null, that says target dot run. Okay, what do we mean? What is the target here? Well, the target here is a variable. It's an instance variable here. Okay, so within the class thread, okay, we have the public class thread, and it implements other things. That's fine. But understand that within this class definition, there is a place where we have a private variable. Type is runnable, and that is called the target. And the constructor is, when we give the target, we give the runnable in the constructor, it is initializing this object. Okay, so from the constructor, yes, this is the target which is getting initialized. Right. So now understand one more thing. We have yet another way of creating a new thread of execution. Okay, having this knowledge that what's happening here is something like this, but that's not a preferred way. The preferred way is what we have done. Okay, there's another way to create a new thread of execution, and that way is something like this. You can say, okay, so steps. Okay, I'll put the steps again. So in this case, you know, in the earlier case, we had a separate class called runnable, right? A class to implement runnable. Okay. Instead, we have okay. So we have a requirement. We, like last time, we had a requirement of a class implementing runnable. Okay. So instead of a class implementing runnable, okay, and override run method. Okay. Fine. One can, okay, create a subclass of thread and override run method. Right? But the problem here would be the overhead of the thread would be part of the runnable. Thread is runnable. Understand this. Thread already implements runnable, and that's why it has the run method also. Okay. The implementation of run method is like this. Okay. So it is in turn invoking the method on a runnable. See, runnable is kept separate, and that's a better option, right? Because with a runnable being separate, you have the option of inheriting from whatever you can decide your own superclass. Okay, in this case, if you are putting thread as a superclass, fine, for implementing your run method, you have to implement run method. Where do you do it? either create a separate class and implement runnable, or create it as a subclass and implement run method. Then override the run method. Okay, so the choice of creating a separate runnable class is a better one, right? You will be able to manage your runnable, the task related things better, fine. You can decide your, one is you can easily decide your super class. You can have it other than what, fine, it's your choice then. Okay, fine. And other way is, yes, we like to keep things separate. See, what is the relation between this runnable and the thread? Okay, so we just say, okay, the runnable is our work. It is defining the work to be done. Fine. And thread is the worker. Okay, thread is the worker who is doing that job. So better to keep the two things separately. The concepts are separate. And as well as what happens is the thread is a heavyweight class. The thread class is a heavyweight class, and therefore just creating your object of, you know, where you want to keep your run method, that becomes too heavy. Okay, right? One class with too many things, it's like that, right? Okay, so it's always found to be a better idea to, right? But yes, if you have this way, right, then your steps would be, what would be your steps now? Okay, in this, the second way, what are the steps? Step 1, create object of the subclass of thread, and where we have overridden the run method. And step 2, set the properties, optional step on this subclass object. Okay, when it's the subclass of thread basically. Okay, and then what's the next step? Start method. So step wise, yes, one step less. Okay, we don't have to separately create a thread object now. It's that object where the run method was written. Okay, so we are overriding the run method, right, in the second case, run method of the thread class. Okay, fine. Okay, so that's another way. Fine. Is the preferred way. Okay, fine. So the preferred way is the way we have done earlier. Right? So, okay, yeah. Also recollect one thing, that our thread is a, sorry, the runnable is a functional interface. There's only one method called run. Okay. So yes, if there is only very small task to be done, yes, you can easily write it in a form of a lambda expression. Right? Run is the abstract method. It's the abstract method of the runnable. So runnable has one abstract method, that is run. Yeah, it's a function interface because only one method. Okay. So one could, you know, even do something like this. You have some task to be done. Okay, it's a very small thing to be done. You could just say, okay, thread th equals new thread. Okay, and here, okay, and write your code. Fine, the code which is to be executed, and you would like to do something. Okay, that code is in just a block. Fine, this block is nothing but the run method, implementation of the run method. Okay, and semicolon and th dot start. Right? Or you don't want to write it separately here, You can just say dot start. That's also fine. Okay. When clear on this? So as a lambda also, someone could just launch something code in a lambda expression, right? And here is the code which you would like to do, right? When the statements to be executed in a new runtime stack. Okay. Okay, so find creating a new thread of execution. Fine. Okay, so yesterday's okay, now let's continue with the methods in the thread class. Yeah, fine. Get set methods, yes. Recollect one of them. Yeah, what were the get set methods we had? Name, okay, priority, okay. There was another called daemon setting. But it's a Boolean setting. Now, one thing important about the daemon, which I have to tell you here is, for daemon, yes, we had two methods, right? One is a public method to return Boolean. Name of the method is daemon, returns a Boolean, and a corresponding method, which is a set daemon. And it takes Boolean, okay, the daemon setting as a parameter, fine. So this pair of method, now here the method set method cannot be invoked on a live thread. Live or once cannot be invoked on a started. Okay, fine. On a started thread, we can't invoke. So once a thread is started, you cannot change the daemon setting. Okay. When we know the difference, what is daemon setting? Right? It's whether the JVM has to wait for completion of this thread or not. Okay. And so if it's a daemon, then the JVM does not wait for it to complete. Okay. Now, how about the initial values for the some of the properties? I think we saw about the priority. When using JShell, we had seen that. Fine. So even we wrote that yesterday. What is the initial priority of a thread? It is the priority of the creator. Okay. Fine. There's one more change which we will get. One more change will also come in that same thing. Okay. It's not necessarily exactly the same priority as the priority of the creator. It is subject to something from the thread group setting also. Okay, we'll see that later. Okay, when we look at thread group, yes, that time we'll see that. Okay, fine. So, okay, what about the daemon setting? What is the initial daemon setting of a thread? Is the what would it be? True or false? Or yeah, yeah. It's again setting from the creator. Okay? So you get these settings from the creator, the priority and the daemon settings. Okay, so if you would like to have suppose because your initial thread is the main thread where you get your control, and that one is a non-daemon. So by default, if you create a new thread, initially it is having a non-daemon setting. Okay, so if you want to start a daemon thread, right, you must first change the setting and then only call the start method. Okay, fine. And if that thread is creating some other thread further, okay, then that would be by default daemon. So from a daemon thread, if you are calling the constructor of thread, it would create a daemon thread by default. And so it's a priority. So these are properties which get inherited from the creator. Okay, fine. What other things we had seen? I think we had seen something about get stack trace. Yeah? Okay, other methods, right? And other methods which we had seen were, okay, I'll put the method names here. There was a method to return boolean is alive. Okay, we had the method to return thread.state, get state. Okay. We even had the method called okay, fine. These are only getting, right? We don't have the setter methods for them. Okay, we even have a thread group, get thread group. Okay, so on a thread object you can ask for the what thread group it belongs to. Okay, fine. Then okay, public, I think I mentioned that stack trace element. Okay, get stack trace. I'm just listing the methods. Fine, these are the methods we had seen yesterday. Fine. Also we had a static method, okay, which would return a map of thread to the map of this. That was a method called get all stack traces. I think mainly this is what we had covered yesterday, right? Okay, fine. Let's look at more the many other methods here. Okay, fine. Now some of the methods will be the ones which will affect the okay. Okay. Yeah. There were some methods available in the thread class. They have been deprecated right in the beginning itself. They came in 1.0 with some methods, and in 1.1 they had to put deprecated. Okay. I explained those methods just to understand, right? Okay, uh, and why they had to deprecate. Okay. So we have a few methods. For example, we have a method, public method returns void. Name of the method is suspend. Okay. We have another public void, resume method. We even have another method called stop. Okay. These are some deprecated methods. Okay. Fine. Okay, I've listed those deprecated methods. No one is supposed to use them. Okay, but yes, what functionality they were having? And they were having, and what is the kind of functionality? So it's something like this. Okay. Okay, I'll show it in that manner. So here is one thread object. Okay, and it has that execution sequence which is working for it. Okay, and this is one-to-one. But then this thread here has created a new thread, has a reference to that thread object, right? Can control that thread object, right? And this thread object has its own, because it was started, there is a sequence which is going on separately. Okay, fine. This particular thread of execution, since it has this object available, right, it can invoke methods there. Okay, and then it says, okay, let me change your priority. It can do all things, right? It can play with its priority also. Fine. A different thread is playing with its priority. A different thread is now saying, okay, it says, let me call the suspend method. So if it was supposed to call the suspend method, what should happen? Calling suspend means, okay, so when it calls suspend, at that time, whatever it was doing, just stop there. Fine. Suspend means, oh, just stop doing anything. Fine, don't proceed further. That stack trace is frozen. Okay, fine, that is the whole idea for suspend. And then he does some more activities and then says, okay, now let me call the resume method. So if it calls resume, what should happen? Oh, wherever it was stuck, right, it was suspended. From there, it will again begin the proceed with the execution. But this is a flawed thing. It's not a good thing. Okay, fine. A very simple example I will tell you why it is not a good idea here. Okay, fine. The idea of calling suspend and then calling a resume on is affecting a separate thread. See, from this particular one thread, this is your thread of execution 1. Okay, and this is your thread of execution number 2. Okay, so one thread is saying, okay, I want to suspend that other thread of execution. Right now, there's no way, it's not a good idea, because you cannot just be suspending at any point of time you like. See, look at a method like, okay, let's look at the method called transfer, which we have written. Oh, we have written a transfer method. Right? Someone called, so this thread, for example, may be executing the transfer method, and in the transfer method, it has to do two things. It has to first withdraw from the from account and then deposit in the to account. It has finished with the withdrawal from the from account, but it has yet to do the deposit part, and you are suspending it. Okay, you are suspending it, and then there is some other thread who is saying, oh, let me go through all the account objects and check what is the total of all the balances here and there. Right? The thing is, it's not in a consistent state. The system is not in a consistent state. Okay, and it will remain in a non-consistent state for a much longer time. Within the execution of a method, right? A method is getting suspended at some point of time, and the point where it is suspended is not a place where it should actually stop. There are logical places within a method where you need to we do look at something like atomicity. Okay, I mean, oh, this has to be done atomically, right? You finish all these, so you cannot. This is like breaking that principle, right? And you cannot be stopping somewhere in between here. Okay, so there are places where you cannot be stopping yourself. So it's not some other thread who can decide when I can stop and when I cannot. See, the thread 2, what is the point at which point the thread 2 should be allowed to be suspended? It is for the thread 2 to decide and not some other thread to decide. Fine. A mechanism can be where there has to be some other kind of a mechanism where a thread can give an indication, oh, I would like you to suspend as soon as possible. You may be doing something, so as soon as possible, please get suspended. Fine. Stop your work. I would like you to stop your work for some time. Fine. Maybe that's a better idea, right? Rather than just saying, okay, just get suspended. Right? Because there are logical places which can only be decided by that thread, not some other thread. So stopping, even stop is a worse thing, right? Suspend was this, okay, that it stops. But if instead of suspend, if someone was calling a stop method, okay, someone calls a stop method here, what happens? Stop method means destroy this. Okay, the execution corresponding to that thread object is completely destroyed. Stop is that kind of a thing. These methods anyway, they were marked as deprecated. Now they are even subject to removal from the API itself. Okay, I just wanted you to understand that this is something which is not a good idea. Okay, and this mechanism has in any way been, it was deprecated, now it's subject to a removal in future API. Stop, suspend, resume, and okay, yeah, fine, clear. So there is, then what is the other kind of a mechanism? We said there has to be some way of signaling. Okay, just signal to the other thread. Okay, so in order to be able to signal to another thread, we do have some a few methods available, fine, where some kind of signaling mechanism is provided for. Okay, let's look at that mechanism. Okay, so for that, yes, we have a let me put the method list first. Okay. So we have this method list like this. Okay, fine. Okay, so now the method which we have is something like that. We have the public method returns void, name of the method is interrupt. Okay, we even have another method to return boolean, name method is interrupted. And we have another static method now, okay, which also returns a boolean, method name is interrupted. Okay, D. So this is a set of methods used for signaling. Let's understand how the whole signaling works here. Okay, look at that last method is a static method, but that means if this method is used, it's meant for the current thread. Okay, it's meant for the current thread. Okay, yeah. Now what happens when interrupt is called? So basically it's something like this. Here is a thread object, let's say, right? And here is a thread of execution which is working. Okay. Our object of thread has a boolean setting called interrupted. And just think, there is a boolean flag called interrupted in our thread object. Right? And calling interrupt, okay, if you say interrupt, okay, no parameters were given to interrupt, it is setting it to true. The interrupted flag is set to true by calling the interrupt method. So the idea here is some other thread of execution just says, oh, I would like to set that. I'm setting a signal for him. Okay, so this thread of execution, fine. Oh, how will he know? No, he will not know unless he checks the flag. Fine. And how about this one, trying to know, has he read my signal or he has not read my signal? I've set a signal by setting it to true. So this guy can also be asking for it. So anyone can ask and look at this thread whether this is currently the interrupted flag is true or false. So the method here is interrupted to return a boolean value. So calling is interrupted is to read the flag value. Right? It simply returns the value. Oh, it is currently set, or it's not set. Okay, fine. Now the way this thread of execution is supposed to read the flag so that it gets reset also is by using the static method called interrupted. So when he says interrupted, okay, so when this thread of execution says interrupted here, it's a static method. So when the interrupted method has been called here, at that point of time, what will be done? It is returning Boolean, remember this. So what this method is doing is, it's reading the flag on its own thread, current thread. See, this is a static method, not called. So this no one else can call. Fine. It cannot affect someone else's thread object. It's only going to affect the current thread's thread object. Okay. So fine. So here, see, if this thread of execution says interrupted, it will affect only. It's only going to read from his thread object, not from the someone else's. It doesn't have a target thread object on which he can call it. It's a static method. Right? So when he says interrupted, it's returning a Boolean value by reading the flag. But it also does the resetting of the flag. It will set it to false. Okay. So whether it is true or false, you get that value as a return value from the interrupted method, which is a static method. Fine. And whether it is okay, also it is doing the second part as setting it to false. If it was true, it will become false. If it is false, remains false. Setting to true, others can set it to true. Only I know how to set my flag to false. I'll read and set it to false. That is the interrupt. So static method is to be used to read the signal. Okay, interrupt method is to be used to set a signal. Okay, fine. Now this interrupt method also has the way it works is we understand how it works, but now there is one more thing about the thread. Okay, now when someone is calling the interrupt method, right, and at that point of time this thread of execution is actually already in a state called the waiting state or the timed waiting state. Okay, we know we had seen this yesterday, waiting and the timed waiting. Okay, how it goes into waiting or timed waiting is not, I have not yet discussed that part. There are certain methods, right, where it may go into a waiting or a timed waiting state. This is, I am not including the blocked state, remember this. So not for the blocked state. Okay, but if it is in a waiting state or a timed waiting state, this waiting or timed waiting may even happen, fine, because of calling some kind of input output. You are trying to read from a keyboard, so that means you are in a waiting state. Okay, or you are reading from device which is slow, so you are actually in a waiting state. It won't take the CPU time. Okay, so fine, you are doing some activity where you are actually in a waiting or a timed waiting state, and if someone calls the interrupt, fine, at that point of time, if someone is calling an interrupt here, okay, what would happen is that method which is actually that blocking method, it's a waiting or a time waiting, it's a blocking method. Okay, fine. So if that blocking, there are other blocking methods as well. I have not there are methods in the thread class. Fine, there are some static methods in the thread class which can also put it into a waiting or the time waiting state. Okay, I'll give one example of that. Okay, we do have a method, a static method. Okay, so this is a static method, returns void, name of the method is sleep, and you give a timeout in milliseconds. Okay, So you are giving timeout in milliseconds over here. Fine, static void sleep method. So there is a sleep method. So if he has said, oh, I want to sleep for 5 seconds, so you'll say thread.sleep 5000. Suppose he is saying I'm sleeping for 5 seconds, right? And someone is calling an interrupt on that. What should happen to that sleep method? Sleep is interrupted. Right? The method which is waiting is actually getting interrupted. Right? So any method which is waiting is getting interrupted, and in such a case, that method comes out by throwing an exception. I was supposed to sleep for 5 seconds, but now I have to come out, and therefore I'm throwing an exception. So the sleep method would throw an exception called interrupted exception. So interrupt one is signaling. It's actually what's happening is it is setting the signal, but the sleep method resets it immediately. Okay, sleep method is it would get the signal and he'll just immediately it immediately reads the signal basically. Okay, fine, and resumes execution by throwing an exception. Okay, it will resume the execution by throwing an exception here. Sorry, here. Yeah, it resumes by throwing an exception. It is the interrupted exception which is getting thrown. The thread is resumed means exception throwing is the action it is taking. So when it is throwing exception, either you have put already in try catch, it will proceed further after the catch. Enter the catch block and proceed further. If you have not put a try catch, this method, this frame is out. But the one who invoked this method, if he has got a try catch, somewhere if it is handled, yes. If it is not handled, it will come out of the entire stack will be down. Yes. It all depends how you have written the code. But it's not stuck now, right? It has come out from the fine. It is going back into the runnable state. State change to runnable. Throwing is an action it is taking, right? Throwing of an exception is an action. It's an execution. So it resumes by throwing the interrupted exception. Okay. It is resetting. Yeah. Now it is set to false. By the sleep, yes. Sleep is actually calling the interrupted. Okay. And resetting, yeah. So it resets and resumes the execution. Yeah. So we also find so this find these three methods, right? They deal with the interrupted flag. Okay, fine. And then I was also mentioning about the static method, which take it into a timed waiting state. Fine. So we have this static method returns void. Name of the method is sleep. Parameter is a long. Timeout in milliseconds. Okay. Has a throws for. It's a checked exception. Okay. So you will have a throws compulsorily. Okay. And this is overloaded. So you may use a more precise time by giving integer for the nanoseconds. Okay. So you might be even giving the nanosecond values. Okay. So and sleep method, it's a static method of the thread class. So just have to say thread.sleep and get the timeout in milliseconds. Okay. Also, we have this one. Anyway, yeah, okay, there's also another thing which we can look at here. Okay, we have a method, or at first write the method name and then we'll see what that method is. So in the thread class, okay, fine, we have a method public void join. Okay, so there is a join method. Okay, and this join is overloaded to use a timeout. So you can specify timeout in milliseconds, or you can have a timeout with milliseconds plus integer for the nanoseconds. Fine. Anyway, all of these, since they are all in waiting state, they have the okay. Okay, let's see what exactly is meant by join. Okay, join is a non-static method now. So it's on a thread object that you are calling a join method. Okay. Here it is something like this. Here is a okay. So there's one thread object and its corresponding thread of execution which is going on. Okay, fine. What it has done is, yes, let's say it has carried out those 4 steps of creating a new thread of execution. That means it created a new thread object, right? Somewhere he has created a new thread object. He wants someone to pass on some of its job to someone else. Okay, do this for me. Okay, meanwhile, I'll proceed further and do my own job. Right? So this has been started, it has started doing some job, and now this thread which created and started the other thread, okay, at some later point of time, at this point of time, okay, it is interested in getting the results of what that other thread has done. Unless that other thread has done its job, I won't be able to proceed further. I can do parallelly till a particular point of time, but then I'm dependent on the completion of the other thread. Right? I now depend on the completion of the other thread. And therefore, what I would do is, I will call the join method on that thread. So I invoke join. See, the one who invokes join goes into the waiting state or the timed waiting state. Calling join here, okay, means this goes into a waiting state. Waiting for what? Waiting for that thread to get over. If he finishes, I'll be resuming. Wait for the other thread to finish. When you're invoking join on an object of thread, for that object of thread, there is a thread of execution. So you're waiting for that stack to get over. Okay, that job to be over. Once it is over, okay, then I'll be resuming further. Then I take my next step. So this is a blocking method. Fine. So they put it into the waiting or a time waiting state. Right? Join means wait for the thread to be over. Okay, if it is not alive, this join will immediately come out. Right? Join with a timeout, so that yes, you want to join, you want to wait for the thread, but you don't want to be waiting for ever or something like that. You want to give a timeout. I don't want to wait more than this much. Fine. In that case, when the time is over, it will throw an exception for the timeout. Okay, so that you understand, yes, there has been a timeout here. Fine. It's not come out because of the completion, but because of the timeout. Fine, the join method. Okay. Okay, now another one. So these are fine. Okay, well, let's one more thing. Let's look at the constructors now for the thread class. Okay, constructors for the thread. We have always till now what we have done is we have used one particular constructor where the runnable is a parameter. Okay, the constructors available are like this. A thread can be created. Okay. So all these are public constructors. A thread can be created by specifying a thread group. Okay, fine. We have not yet discussed the thread groups. Okay, fine. But that's the next thing we'll have to look at. So you specify a thread group. You specify a runnable. Okay, that's your target basically. You specify a string for the name. Okay. Name of the the name of the thread. We have that get name set name method as well. So initially you can set a name while creating the object also. Fine. You can still have one more slightly advanced option is to use a long, right, which is this long is your stack size. Size for the runtime stack. This is rarely required to be used. Okay. Okay. So we have this overloaded. I'm starting with the most number of parameters which we can have. Okay. There's actually one more overload. Okay. I'm not writing that here, fine, because it involves use of another kind of variable known as thread local variables. Okay. I'm not discussing thread local currently. Okay. But otherwise, yes, there is a Boolean setting also, which you can have inherit. Whether thread locals need to be inherited. Okay, fine. You can ignore that setting for the time being. Okay, but yeah, then we have thread. So now the constructors are like this. Overload is this way. Okay, so that's one more. Okay, and if you copy this, okay, you can give runnable and the name. Target runnable, fine. The thread group runnable and name, or you can use thread group and runnable. Okay, yeah. And then the next set of constructors are like this. They are without the thread groups. So these are the ones with the thread group, and others are without the thread group. So you don't have a thread group, just the runnable and the name, or just the runnable, the one which we have used. Okay. Or you may even use just the name only, or the next thing would be okay. So that way this thread, the thread constructors are overloaded. Okay. Fine. So constructors are like this. So what comes here through the constructors? What we find is a class called thread group. Okay. So what is a thread group? Okay. A thread group has been used for organizing the thread objects. See, understand, threads are objects. When we are referring to the class thread, we have objects. It's not the thread of execution we are referring here. How do we organize these thread objects? Fine. Okay. Fine. We said, okay, I'll use a slightly different analogy now. Yesterday I put the analogy of a thread of execution, right, is like a person. A thread is nothing but the profile of that person. Okay. Thread, because thread is a place where we keep something. It's an object. It's not, it's a, when we talk of the thread of execution, that is a living object, whereas these are all dead things. But yes, you keep them, right? So you store information into these things. So object is used for as a storage of information. So thread object is that storage of information. And so when we talk of a thread group, it's about organizing these thread objects into a tree structure. There is a hierarchical structure in which threads may be organized. Just like we have a hierarchical structure for managing our files in the file system. It's a tree structure. Hierarchical means the tree structure. Right? We have a root directory, and then we have the subdirectories, sub-subdirectories. In the root directories, we may have files. We can keep files everywhere. So same way, a thread group is giving us a tree structure, is useful for giving us a tree structure. Okay. Right? So we organize our threads into a hierarchical structure by using the thread groups. Right? It's something like this. Yes, now the way things have been done, okay, the way if we explore the things, what we find is there is one thread group, okay, which is at the top, which is the parent of all other thread groups, and its name. Okay, here, like threads have a name, even thread groups have a name. Okay, so thread groups have two properties, fine, which are read-only properties. These two are sorry, the name is not a read-only. Name is a read-only. Yeah, name is a read-only. Both of these properties are read-only. So we have a name. So thread groups have a string name and parent. Two things in a thread group, which are read-only. So parent and name are decided at the time of creating the object. When you create a thread group, yes, you have to specify the name and parent. Okay. So constructors for thread group, okay, there are constructor for thread group. Parent is a must. What is parent? It is of type thread group. Right? Initially, the thread group which is created for us is known, has a name called, it has the name called system. Okay. This has a child thread group rather. Okay. Basically, when the thread called main, a name is main here. When this is created, the parent is specified for this as the, so it has a parent which is the system thread group. System thread group's parent is null. Fine, system thread group's parent is null. And we have a main thread group whose parent is system. Okay. In this thread group, main thread group, we have the thread objects. So I'm showing with smaller circles, right, the thread object, and this thread with the name called main. So initially it is the main thread which is created, and it has been started. It has a thread of execution. Okay. Oh, we have the garbage collector related threads. Oh, they are here. Fine. So we have some threads under. So this also, like there is only one thread under the main thread group. Under system thread, you will find a number of threads being existing here. Okay. Fine. We may have a look at it using JShell. I think yesterday also we saw that JShell, there were a number of threads created. Okay, now when we use JShell, the JShell is also creating its own new threads, and those threads are created under the main thread. So you might find a couple of threads more when using JShell. Okay, fine. We'll have a look at this through JShell, but a few additional threads under the main thread group may be found because we are using JShell. But if you write your code and try compiling and running the code, okay, those threads would not exist. Fine. Okay, so fine. So okay, fine. I think what I'll do is first let's discuss the class called ThreadGroup, other aspects. Okay, and then let's check that out. Okay. Now, what does this ThreadGroup have? One thing is, basic thing is, to give us a tree structure, it has a concept of a parent. Every thread group has a parent thread group, right? And all thread groups are identified by their names. Okay, so they have a name which is of type string. Other than this, one of the things I was mentioning was related to the priority. Okay, threads have a priority, right? And threads, every thread will belong to some thread group. Oh, when we saw some constructors of thread where we don't pass a thread group, then what will be the thread group of a thread which is being created without specifying the thread group? It will be the thread group of the creator. See, everything comes from the creator. Priority came from the creator, right? Thread group also comes from the creator. See, if this is the main thread group, right? This is the main method, right? And it is saying, let me create a new thread. I'm not specifying in that constructor, if I'm not specifying the thread group, it would be created under the main thread only. And this JShell created new threads, two separate new threads. It didn't mention the thread group there. And therefore, they belong to the main. This main thread, which is here, has the parent as, has a thread group, which is main. And therefore, when it creates new thread, by default, they will be here. If while creating, it could have specified system also as a thread group, then they would fall there, right? Or it created its own new thread group. Fine. Someone can fine. You can be creating a new thread group also of your own. We have the construct of thread group like this. So thread group, how it can be created? Okay. Let's look at the constructors of thread group. So if you want to create a thread group, you can specify a thread group, which is the parent. Okay. So you can specify a parent thread group and no name also. Sorry, parent thread group and a name, sorry, and a string for the name. Name is a must. Okay, the constructor for thread group is overloaded, where you may only specify the name and create a thread group. So if, while creating a thread group, if I have not specified the parent, what is the parent then? What is the parent of a new thread group? It will be the thread group of the creator. So if the main thread here says, let me create a new thread group object, and while creating the thread group, it has not specified the parent. It could have specified parent as system. But if it has not specified the parent, then what is the parent thread group? Or the parent thread group is the main thread group. Because that is the thread group of the creator. Fine. So yeah, so every thread group always, when you create a new thread group, it will always have a parent thread group, even if you are not passing it as a parameter. Fine. All threads belong to some or the other thread group. When you are creating the object of thread, the creator's thread group is used as a thread group if your thread group is not mentioned. If you don't mention thread group, it will fall under the creator's thread group. Okay, fine. Now a setting which we have in the thread group. Two things are there in thread group. One is name and a parent. Other than this, one more thing which we keep here in a thread group, which you can always change. So we have a get and set method in the thread group for max priority. Max priority. So we have a get max priority, set max priority method on the thread group. Thread group has the max priority. Okay, fine. So when a new thread is created, suppose there is a new thread group which is like this, right? This is a new thread group which has been created, and now someone uses this thread group and creates a new thread object. In the constructor, use a thread group to create a thread object. Fine. So if this is done, but one thing here, what has been done here is it has said, okay, your max priority here can only be 7. Suppose the max priority has been set to 7. Fine. And someone creates a new thread object. Fine. And when creating the new thread object, suppose the creator's priority was 9. Creator's priority is higher than the max priority for the thread group under which a thread is being created. What will be the priority he will get? He'll get 7. It's a lower of the max priority. It cannot exceed the max priority available for the thread group. A thread is created under a thread group, and it cannot be, the priority which it gets cannot be more than the priority of the thread group, max priority available in the thread group. One more thing here, it does not affect, you call the set max priority and change the priority here. It will not affect any of the threads which are already having their own priority earlier. Subsequent, any new thread being created or subsequent invocation of set priority on a thread object will use that value. Okay, fine. So if the max priority has been changed to 5 here, okay, and on this was already running with a priority of 7, and if I say let me set the priority to 6, it will become 5. While it was running at 7, it will keep running at 7 because I changed that priority subsequently on the thread group object. Max priority was changed, and max priority was changed to 5 now. And someone says, okay, let me now change the priority of the thread which is working under it to some value. It will be subject to the max priority. The max priority of any executing any thread object is not going to be updated because you said set max priority on a thread group. The current thread's priority will not be changed. Any invocation of set priority is going to be affected. That's going to use the max priority. So when you create a new thread object, it is actually basically calling the set priority method there by looking at the creator's priority. Fine. So in the constructor for thread, when the code is thread dot set priority, okay, new threads, this dot set priority, okay, thread dot current thread dot get priority. Okay, and set priority, the method set priority does a check with the thread group and sets it to the minimum of the priority which you are trying to set and the max priority available for the thread group. it will be set to the creator's priority. Acha, creator has a priority. Thread group have a max priority. Creator is a thread. It's a thread only. See, who are the workers? They are all threads. When the thread of execution, each one has its own thread object where priority exists. Every thread object has a priority setting. It's a property. It's for an entire group. When it's for a group of threads. Okay, fine. So thread group can be used also for a group activity. Let's see that also. When there is a method in the thread group called interrupt. Oh, that interrupt which we have seen. Yes, it's that same interrupt in the thread group. Calling interrupt on a thread group means calling interrupt on all the live threads under this thread group. A group activity and something to be done on the entire group. Yeah. So you can call interrupt on a thread group also. Okay, so calling interrupt on thread group is like calling interrupt on all the threads under the thread group. Okay, fine. There are other methods which are also group activity. I'm not putting them now because they are all deprecated and going to be removed. Which are those? Stop, suspend, resume. So they were also available in the thread group so that you can do it on a group of threads. Okay, but anyway, that's going to be removed. So those methods are deprecated and subject to removal. Okay, fine. We have a few other methods. Another method is a method called list. So you can just try list method, and this is something which we can try out and see what's the output here. Okay, there is a method called enumerate. Fine. So okay, we have that other method enumerate. I'll come to that later maybe. Yeah. Okay, but some important method. There is one interface implemented by the thread group. Thread group implements an interface called, so there is an interface called which is implemented by thread group. It's called the uncaught exception handler. There is an interface called UncaughtExceptionHandler and it has only one method. This interface has one method called, what's the method name? UncaughtException. Fine. This has a method returns void. Name of the method is UncaughtException with two parameters. First parameter is the thread object and second parameter is the throwable object. Sorry, throwable. LE. Okay. Thread and a throwable. UncaughtException is a method. Fine. Part of the interface called UncaughtExceptionHandler, and thread group is implementing this interface. Okay. Fine. What is this UncaughtException method? It is invoked when a thread will terminate because of an exception. See, a thread coming out of main method because it was never handled. Fine, fine. We understand that stack trace in the stack, the topmost frame, it had an exception, and then it was never handled. No one was catching that exception, and therefore it even turns out of the main method. Or in case of other kind of threads other than the main thread, it is coming out of the run method. So when this has terminated, right, a thread has terminated because of an exception. If a thread terminates because of an exception, then what do? Oh, normally what you find is a stack trace being printed. Right? You have seen that you are seeing the output of a print stack trace, and that's because the implementation of, in the thread group, the implementation of uncaught exception is, it has two parameters. What are the two parameters to this uncaught exception method? Because this is invoked when the thread is terminated because of an exception. Right? So it is saying this is the thread which has terminated and this is the exception which was thrown. What do you want to do now? It's just giving us a, right? It's giving us a control. Okay, this is a thread which terminated and this is the exception it has thrown. What do you want to do with it? And the code for that is, okay, let's do a print stack trace. That's how you are seeing the print stack trace. The thread group has implemented it that way. This is the method in the thread group which has been implemented that way. Oh, you want to change that idea? No, I don't want to see the stack trace. Maybe I'm interested in restarting the thread again. How will I restart the thread? We have those steps. I've got a thread object which is a runnable. I might create a new thread object by using that thread object and call the start method. It will get started again. I'm just giving you some idea. So the idea is you have a thread object available. This is the thread which has just terminated. Okay, fine. So you are getting that intimation. You want to change the way it is doing, or maybe simply put a simple println or something. I don't want to print the stack trace. I don't like the stack trace being shown to anyone. Fine. Or maybe I would like to change the format in which the stack trace is printed. Let me use the get stack trace and do something else, right? I have to put it in log also, right? So you might be interested in doing so many other things, not the standard way of just printing the stack trace. So one option is to create a subclass of thread group and override this method. Okay, but that's the way it was done prior to Java 5. Okay, but from Java 5 onwards, we have a separate interface. This interface, sorry, not a separate interface. This is that interface which was introduced in Java 5. Earlier, this method existed in the thread group. The thread group already had this method, but in Java 5, this interface was introduced. It was put as an interface separately, and then a few methods were added into the thread class, where you can set up your own custom uncaught exception handler, fine, for a specific thread object, not the entire group, for a specific thread object. I want the custom exception handler for this. Or, by default, whatever is happening for all threads, okay, you can even set up that any thread, if it terminates because of an exception, this is what should be done. Okay, so we have this as an interface. You can create your own class to implement this interface, write your own exception handler, uncaught exception handler, and then set it on a thread object or set it as a static method. Fine, using a static method. So I'll put that API part here. Okay, fine. Yeah. So okay, let's go back to the text and let me put something. Okay, so what we have seen, okay, so thread group. Yeah, what are the things in the thread group we have seen? Can be created with the help of a thread group as a parent and a string for the name, or you may use and just the name. Okay, we have the methods as, I'll not include those deprecated methods here. Okay, fine. Okay, what are the methods? We have the methods for okay, a method to return a thread group, get parent. Okay, we have the method to return a string, get name. We have the get set methods, int get max, max priority, takes int max priority value. Okay, get set for the max priority. Yeah, okay. Okay, I also talked about another method which was the okay, implements. Okay, uncaught exception handler is an interface under the thread. So it's a nested interface. Inside the thread, we have the uncaught. And that's an interface we have. Okay, it's an interface. And here is a method to, because it's implementing that, because of that, we have this method called uncaught exception. Parameter being, first parameter is a thread object and second parameter is a throwable object. Okay, and this throw, fine. So it's an indication that some thread under this thread group, and that's a thread which has terminated because of exception. It's not, normal termination is not going to do anything. Okay, fine. When a thread terminates because of an exception, yes, then this is what is the method invoked. Okay, so prior to Java 5, the way it was, we didn't have this interface. We had this method here. Okay, and this is the method which, so if you wanted to customize it, we had to create our own subclass of the thread group and override the method, and it would become applicable only to the threads created under that new subclass of the thread group. Okay. Fine. So it was a very cumbersome method. Fine. So in the thread class, okay, related methods, right, are like this. Public method returns void, okay, set uncaught. Set uncaught exception handler, and I'll not put thread dot, that you need to understand, it is thread dot. Okay, name of the method, so parameter here is the uncaught exception handler. Okay, this is okay, h handler. Right? So this is one method, and also the other method is, instead of set, you might be actually using the get method. Okay, so we have the get and set method for the uncaught exception handler. Okay. Also, another couple of methods, which are the static methods. Sorry. We have these as a static method as well. So, static void set default uncaught exception handler. Okay. Okay. And same way we have the. So, if you say default, that means it's for all the threads, fine. There's a get method. Oh, sorry. Okay, it's an uncaught exception handler, and yeah. Okay, so these are some methods from the thread class. So if you use the static method, it would mean any thread termination, unless it has its own. See, individual thread objects have their own uncaught exception handler, which is possible. But if you have not set them, it would be null. Okay, setting of uncaught exception handler is null by default. The default uncaught exception handler is also null. Okay, thread group is an uncaught exception handler. So when a thread terminates, by default, what would happen? Oh, the thread group's uncaught exception method is calling, is getting called. Fine. Now, whenever a thread terminates, what will be seen? It will be checked whether it has an uncaught exception handler setting. If it is there, use it. If it is not there, let's see the default. If default has been set, use it. If default is not set, then go by the thread group. Okay, go to the thread group. So thread group is always there, because the thread which has terminated belongs to a thread group. So that thread group has an uncaught exception method. Okay. Anyway, I'll put another analogy to this, and we'll look at it tomorrow. Fine. This, yes, we can look at it, and we'll try. Jeshal, we can try with this example also. Okay, so we continue tomorrow.